Hi everyone, this is Patrick Palucci with Slooh Space Camera. It is July 9th, Tuesday at 11:10 a.m. Pacific Standard Time or Daylight Time, and I'm here today with a special solar show giving you a live view of this amazing sunspot activity that's taking place on the sun currently. The name of this sunspot is AR1785, and what makes this sunspot so significant is the size of it. And what we're going to be doing today is giving you a live view of it from a world-class observatory located in Prescott, Arizona. Now, on with me today is longtime Slooh friend and observatory owner Matt Francis. Matt, how are you?
I'm doing good. Thank you, Pat. Glad to be here looking at this sunspot today.
Excellent. So, for those of you who don't know where Prescott, Arizona is located, I'm going to show you really quick Matt's location before we get rolling so you understand what's happening here. This is going to be loading up a Google Earth little map. And unfortunately, this is the same location where all of the 19 firefighters recently passed away. So our thoughts and prayers are out to those families who lost loved ones. Um, it's really too bad. It's the wildfire situation out there has been bad. Hopefully, Matt's been telling me it's contained, and so that's good to hear. But we're also sorry to hear about the death of those firefighters. Matt's facility of it that I've put together that are from a previous show, and that's the supermoon, as you can see. Other nice shots here of Matt's facility looking at. So this is a significant facility that Matt owns and operates, and he's a significant partner for Slooh. So what I'm going to do now is bring in these live feeds of the sun. I know that's why we're all here is to see this. Matt, I'm going to bring this up right now. Why don't you tell us what we're looking at as I load this stuff up?
Okay, so the live view shot is the full solar disk here, and you can see the active region towards the western limb, the right side of the sun here. And they this sunspot has actually defied the odds because it's so active that it was forecasted to produce an M-class flare. It still is actually above a 50% chance to produce at least an M-class flare today or tomorrow. Um, and so that's what we're looking at here. There's a very large sunspot to the right. You can see the dark sunspot, and just to the left of that is active region 1787. That region is a little more pointed towards Earth now than 1785 was, but I think if they were to produce a CME today, it's likely that it would still, at least at a glancing blow, strike Earth.
Yeah, and in fact, a couple of things, guys. If you're watching this on Slooh.com, the homepage of Slooh, you're also getting a high-res version of the sunspot location provided from these feeds. So you can also see the feed itself through the live video that we have, but also a high-res version of it is also located at Slooh.com. So you can go there as well. There's also a Slooh conversation section, so go there if you want to ask some questions. That's where we will take them if we have time. This show is about 25 minutes today to about 11:30 a.m. Pacific. So if we have time, we'll try to get to them. But you can also interact with space explorers around the world who watch these shows. So what we're going to be doing is giving you different looks. Matt's at some point when we get further along, we'll zoom in on some of these flares and some of this other activity that's happening on the sun. What you're looking at right now are live images coming from Matt's observatory in Prescott, Arizona, and we're looking at this significant sunspot that is currently rotating around Earth. Now, Matt, maybe you can tell us. I like to always step back a little bit because a lot of our watchers know very little about the sun, and very little about what it is. And I know some of you out there maybe get offended by this, but the sun is actually a star. And Matt, maybe you could talk more about what you know about the sun because you obviously image it
Sure.
frequently and share your thoughts on it. And I'm going to bring up, while we're looking at some of these live feeds, I'll show some other images that you took recently of the sun to show some of the sunspot activity that we'll talk more about in a second.
Sure. Well, as I'm talking about this, I'm going to be referring to the live image. So the sun has an 11-year active cycle, which we're right at the peak this year. So that just means that the activity on the surface, or what we call the photosphere of the sun, is very active. And when I say active, that just basically means that there's a lot of magnetic activity. There's a lot of the sun is essentially a giant magnet. And so what we're looking at here in this live image of the active region 1785, you can see there's the dark sunspot, where what that is a giant magnetic field line that is exiting the photosphere of the sun and being drawn back in at another part by an opposite polarity region. It's dark only because as the magnetic field line exits the sun, it separates the photosphere in that area and creates a cooler region. It isn't really dark. If we could fly to the sun and look at that region in itself, it would be blindingly white. The image that Pat just loaded here, this is a close-up of the active region, the large 1785 sunspot active region. So, okay. So now, if you see, there's also bright areas around the region there, and that's called faculae. Those are the sun. The photosphere is very granular. It's very rough, and if you can imagine, almost like if you can imagine like grains of rice blown up to, ridiculous proportions. In between the grains of rice, there would be canyons. And those bright areas called faculae, those are also high energy magnetic field lines that are spreading out between the canyons, between the solar granules. Now, if you look above the active solar region, you'll see a dark line going across. That's a filament. And this is also a giant magnetic region. It's actually a large filament that's hovering just above the photosphere. Also, slightly cooler. It contains slightly cooler plasma than the photosphere does, and that's why that appears dark. Filaments are typically very unstable, so we watch filaments closely because they can, without warning, explode. A lot of times before what we call a coronal mass ejection, a CME, there will be a solar flare that's a warning that a CME is about to get loose. The filaments don't have that. They just go, so without warning. So anyway, as you're looking at this active region, you'll notice it's a little bit to the right of center. That's because that's the rotation, the sun's rotation. It's actually moving away from our line of sight at Earth. And tomorrow, if we were to look at this tomorrow, it would be closer to the right side of the solar limb. We typically watch the left side of the sun, or the eastern limb, and we watch for solar prominences on the limb, and that tells us that there are active regions that are coming into our view, turning towards Earth, and will be facing us in the next week or so. And that's what we're looking for.
So Matt, what I'm going to do is you pulled up. You wanted me to share some of the recent images from the NASA SDO, and
Yeah.
I'm gonna feed those in. This was more of the close-up version that you wanted. Maybe you could talk to us about what exactly that, because it actually matches what we're seeing live, which is going to be interesting. And I do want to send out a quick note. I noticed if you were on the home page of Slooh.com, you may need to refresh. There was an image. The image wasn't loading properly, but now it is on the main viewer to get a high-res image. So just for those of you watching on Slooh.com, where you can see a high-res version of the stream that we're providing right now, you may need to refresh your browser to get that new image that we got up there. But anyway, I'm going to share this with Matt. Went ahead, and Matt, maybe you could talk about this, but also if possible, this would be a great time to do the camera switch. If you can do that at the same time. If you can't, I can talk about some other things as well while you're making the zoom in version of the.
I can do that, Pat. I just loaded another picture. Um, it's a you had a color picture up there before, a close up of the sunspot active region. I just loaded another picture of that. This is not in color. This is actually what the surface of the sun would look like if you could fly there and dim it so that you could actually see detail. I just loaded that to the server. So if you could put that one up, that'll help with this illustration. Um, Maybe we could switch between that and the SDO image.
Yeah, I have right now. I have your live shot of the disc that we've been looking at, and I have the SDO. That's all that's available to me right now of those shots.
Okay, I'll tell you what.
I can't
Put
pull.
the SDO image. Put the SDO image up there, and I'll switch cameras on the live shot to the close-up view,
Right, that's exactly.
and we'll do that.
Go ahead and get a close up going. Just a quick
Okay.
note why Matt's doing this is we were looking at some NASA SDO close ups that we'll talk about in a second. If you do own an iPad app, I highly recommend that you download our free iPad app where it's an interactive sky chart. You can actually go in and book command missions right on our network of what we call space cameras. So it's really cool how that works, and that includes the sun. And so those of you, when you do book a mission on a space camera, you're actually getting a live image taken that day or that night or whatever it is, scheduled permitting, and you do get updates. So it's a new product. Take a peek at it. It's been out a couple months now, and we're really fired up about it. And you also get access to all our live shows. And I can kind of show you really quick. I've been doing some solar missions myself, having some fun with this, and I'll show you guys really quick here some of this so you can see it. Hold on. So yeah, this is like a mission I actually commanded myself, and you can collect all your images right into these what we call an image bubble, and these are all in an interactive sky chart. And I'll give you an idea of a couple others that I've done. Here you can see as well. Why Matt is currently looking into another shot here. So yeah, it's a free download for iPad users in the iTunes store. And Matt's actually got another close-up going of the sunspot. Now this is live. Man, this is awesome, man. I like this one better actually. Let me go ahead and put the marks
Okay.
up. But yeah, I'm showing this in right now. This is live from Prescott Observatory in Arizona. This is the very active sunspot area AR1785. Now, what's going on here? This poses no danger to Earth just yet, but it is pointed right at Earth or pretty close to right at Earth. If a flare was to go off, they were worried about this thing putting out an M class or X class flare. Maybe you could talk to us really quick, Matt, about that, what that means, and if it did happen, what would happen on Earth?
M-class flares are high energy flares. They typically do not cause widespread ground-based damage. X-class flares are different. That's the highest energy flare that can be produced, and they can cause anything from satellite communication disruption to um, uh, widespread power outages. Um, so that's the danger. And this region on the sun that we're looking at now is so large that there was a concern that it could produce an X-class flare. As you said, as you said, Pat, it has rotated a little past in our direct line of sight.
Right.
So it could, if it were to produce an X-class flare now, it's impossible to say with certainty, but I think it's likely that it would produce sort of a glancing blow to Earth at this point as it rotates towards the back of the sun.
Yeah.
So,
What I was going to do, Matt, really quick, since it's so similar, like that graphic NASA shot you sent me to
it's
use.
the exact same thing. Yeah,
Yeah,
I
look
want
at
you
that.
to.
It's like I'm just overlaying it right now in the broadcast. Do you
Okay,
know what the
good.
green and the yellow and the blue represent? Are those is that a thermal, or what is that?
Yeah, okay. So if you have that up now, do you have the wide angle version or the close up?
The close up, so it matches your
Okay,
current
good.
shot.
Okay, perfect. All right, great. So we're looking at that, and you'll see on the NASA SDO magnetometer, this is, or a magnetogram, this is uh, a, a, a graphical representation of this exact active region, and it shows the polarity. Let me just adjust the exposure here as I move in and out of clouds on this picture. It shows the polarity of the active regions here in this sunspot. So what we're seeing here, you can see the main dark sunspot, 1785, and you can see that it's blue around that region. Can you see that okay, Pat, that it's blue?
Yeah, no, we're seeing that
Okay.
perfect.
That indicates a positively charged polarity in that region. The regions to the right or to the left of that are red, and those are the negatively charged polar regions. So as magnetic field lines exit that large area, they will move towards one of the red negatively charged regions on the photosphere there. So that's where they'll enter back into the sun. And what's interesting about this and what's informative is that not the large black, the main sunspot where the most of the blue is, sort of in the middle there, just to the left of that, you can see a region where there's red and blue right next to each other. They're in very close proximity,
Right.
and that indicates a very strong energetic region with a likelihood of producing a CME. When the sunspots are further apart and the opposite polarities are not so close together, the chances are a little less that they'll produce a CME.
Right.
But as you can see, this active region that we're looking at today has right almost in the middle of it has a negative and positive regions that are just right next to each other, and that was one of the concerns here.
Well, this graphic matches perfectly what we're seeing live here from Prescott Observatory in Arizona. Um, so this is really cool that we're able to kind of see how they image this and what it means. Now, as we keep moving through the broadcast here, Matt, is there any? Are you able to see any flares right now in this shot that you've got, or is that a whole different camera setup?
Well, I'm glad you asked that. So uh, let's see here. Yes, I'm copying a picture right now up to the Slooh FTP server. So yeah, actually there's a huge flare going on right now on the western limb of the sun. We don't have to worry about this because it's rotating towards the back of the sun. But it is truly gigantic. Um, and that should be coming up to the server any minute now for Slooh. Um,
So yeah,
luckily,
what Matt's referring to is basically if you're on Slooh.com, you also get the access to a high res version of the live video shots that we're providing in the live stream. So if you're watching this on YouTube Live or somewhere else, if you go to Slooh.com, you can actually get another image that's sometimes in color even. So anyway, if you guys have any questions you want to ask Matt or myself, just go to Slooh.com and hit that Slooh conversation button, and we'll try to monitor it. We have about 10 more minutes in this particular broadcast as we are looking at a live feed. We started a little late due to cloud coverage today, but we're able to go through this. Now, some of you, just so you know, some notes. These broadcasts are available to watch later if you want to catch them later. You just go to our YouTube channel and you can subscribe to them. That's one of the easiest things to do. Um, and we'll try to keep you updated. You can also follow us on Twitter or Facebook or any of those areas, and we'll keep you updated too on future shows. They also typically will count down on Slooh.com, so you can go there as well. Now, some of you were asking about the predictability of these flares. Matt, do you know much about how predictable these flares are? Um, when we
uh, unfortunately, they're really not that predictable. As odd as this sounds, as close as the sun is to us, we really know very little about it. I mean, we are learning a great deal from the several orbiting satellites we have now, Stereo A, Stereo B, SOHO, SDO, all these satellites we're gaining a lot of information on. But as Bob has sometimes talked about, it's only within the last, I think, 2 or 3 years that we discovered there's a sun within the sun turning at a differential rate, which is thought to be the origin of much of the magnetism that the sun is inherent to the sun.
Right.
So it's not we're not able to predict with great certainty when a flare will happen. We watch the active regions, we watch the amount of faculae that's produced in those energetic regions, we watch for the proximity of negative and positive polarizations, and that's really what we go by.
Well, if what we're looking at now is live views of the sun. This is live from Prescott Observatory, and those flares are massive. So for those of you we're looking at this and it doesn't look that big, these are much bigger than Earth, aren't they, Matt?
Oh, several Earths would easily fit. This flare that we're looking at, you see the looping structure of it, right? You see it commencing from one part of the sun, looping through space, and going back into the sun. I think that's pretty obvious in this shot. So yeah, in between, and again, this is a positively charged region going to a negatively charged region, and yet several Earths would easily fit in between these two regions.
Yeah, that's what's fascinating about this stuff. And people, I think sometimes we forget how massive the sun is, but actually, as far as a star is concerned, it's not that big when you compare it to other stars that are out there in the universe. And it always kind of, when you start to, it's sort of mind-boggling to start thinking about how big some of these stars and suns are. And ours is what, isn't ours considered like a mid-tier star in the whole scheme of things?
Yeah, it's just a very average main sequence star. When our star finally does go nova, it won't come anywhere near producing a black hole. It will turn into a white dwarf. It's just it's a very average star actually, and certain there are stars millions of times more massive than this, like the one at the center of our galaxy that has collapsed into a black hole.
Right. Well, and that's what's interesting too about this, because it seems like now they're finding out. Because when I remember growing up, and you probably do too, when the talk was that there was only one Earth. Now all of a sudden, even on our own galaxy, they're making discoveries that there's probably a high probability of life on other planets and star systems because of the location of other planets around it. What are your thoughts on that, Matt?
I think that most astronomers and cosmologists recognize the statistical probability of intelligent life existing in our galaxy and elsewhere in the universe. It's now thought, well, with all of the, again, with the orbiting telescopes and detectors we have now, we know we have approximately 1,000 confirmed planets around other stars in our galaxy, and we have another 1,000 candidate planets.
Right.
So as those candidate planets are confirmed by ground-based telescopes, which I expect they will be, I think the model for stellar evolution, as stars evolve through time, I think that planetary formation is really just an incidental result of that. So yeah, the chances of other planets being within the habitable zones of other stars, I think, are very good as far as intelligent life existing. I don't think there is by any means a large amount of intelligent life, because as far as we know, you need to be within the habitable zone. You have to have liquid water.
Right.
The planet can't be too large, or the gravity will be too much. But I certainly think that there's a good case for intelligent life.
Hey, Matt, is your mic changed a little bit? I'm just giving you a heads up. It might be a little choppy. I don't know if something's changed on your end, but we're getting close to wrapping up our show here. We've got about 5 minutes left. We're looking at live feeds from Prescott Observatory in Arizona of the sun. We shifted over to some massive solar flares. We talked earlier about this big sunspot, AR1785, and we talked a lot about that. So we went over and Matt found these flares going off. So we wanted to show you guys these things. And I was looking at the conversation section, and people are asking if there's do we have a chart of the Earth compared to the Sun? Unfortunately, I do, but I don't have it in this broadcast setup. So basically, the Earth, generally speaking, would probably fit in that coronal loop that you're seeing right now that's forming. It looks like there's like a loop that's, if you're looking at the live feed, you're seeing this loop that's forming. And I'm sure an Earth or two would fit into there easily. And people are asking about an iPhone app. Are we going to come out with one? And the short answer is yes. We're kind of in this soft launch with the iPad app that we came out with. We wanted to kind of tweak things, make sure we got it right, make sure we could service it properly. Because what you do in the app, when you command a mission, now you download the app for free, just to be clear. But if you want to command one of our robotic space cameras, you have to pay for that. Now we do set up what we call top missions. Those run $1.99 US, and you just do it in top missions for that, and we update them almost every other day or so. If you go off the top missions, you can pick any mission out of the sky chart at any time. You just will pay more, and believe it or not, a lot of people do, and you get some fascinating stuff. I mean, you can collect the phases of the moon. You can go off and do some solar missions. You could go off and check out what Saturn looks like, and we give you updates in the mission status screen. So once you do command a mission, it can take days. I mean, I just want to be clear. This is a live thing. We don't give you any pre-produced images. Once you book a mission on it, we're going to fire up one of our observatories. So weather permitting, schedules, it can delay it a little bit, but generally it's pretty quick. So just to be clear, and I'll show you guys really quick before we get off here. Here's something I did with the moon. I actually booked this mission just recently. I'll just show you really quick here. Let me just get it set up. Here's one of the moon that I did, and we do special stuff like high mag versions, so you're not getting always the same look, especially on objects like moon or Saturn or something in the solar system. Usually you'll get different looks, and of course the sun today, you'll get a fantastic image of the sun, as well, as we're using the observatory here in Prescott with Matt Francis. So Matt, we're about to get off here, guys. It's we've been on now for about 30 minutes, which is the time of our show. Matt, any last thoughts before we get off today?
Well, I'm just happy that this active region did not produce a CME that was pointed directly our way. I think it would have been a very large one had it done that. But we have the rest of this year, next year, and probably the following year of high solar activity. So it should be very exciting to keep watching this.
Yeah, and we'll do a lot of solar stuff with Matt and his observatory in Arizona. We're working through that. We also, the next upcoming show right now is tentatively scheduled for Thursday, Deep Sky Mysteries with Bob Berman. Right now that show is set for 5 p.m. Pacific, 8 Eastern. Again, that will be live, but you can also get the recording of it at our YouTube channel, Slooh On Air Videos. That's our YouTube channel, and you can catch the recorded version of that as well. And we also do a lot of other stuff, so we'll keep filling out the schedule over the next couple of weeks, and you can always get updated on the homepage of slooh.com, or you can go to our YouTube channel and look for which ones are coming down there as well, and we'll keep you updated. And subscribe to our Twitter feed, or follow our Twitter feed or Facebook page or anything like that. We'll keep you updated there as well. And Matt, wow, you're really there's a lot of activity on these flares, man. This is a really cool way to end the show.
Yeah. Again, this is the western limb of the sun. We could, I think it would be interesting to maybe just at the very end of the show, let's go over to the other side. This is the side that shows what is coming our way, and I believe there is some activity on this side. Yeah, there is some activity towards the north side of the sun, as we can see.
Right.
Can you see that, Pat? Yeah.
Yeah.
So
yeah,
we do have stuff coming our way. Definitely, some activity is coming.
Cool. Well, we'll make sure to get on that, because I'd love to do more of this stuff. It's very interesting to see, the sun and to see it live so close up. That's what makes it special, to see these prominences and everything else going on. So, all right, Matt. Well, I appreciate your time today. I look forward to doing another show with you in the near future, and we'll talk to you guys later. Also, guys, you may consider, if you're a diehard, there is a membership link on Slooh.com. If you own a telescope, you can command our robotic observatories in the Canary Islands, and you have a lot more access to FITS data and other more advanced tools that may be of interest to you as well. For Slooh Space Camera, this is Patrick Palucci. Thank you for joining us.
See you, Pat.
Bye-bye. So what I'm going to do now is bring in these live feeds of the sun. I know that's why we're all here is to see this. Matt, I'm going to bring this up right now. Why don't you tell us what we're looking at as I load this stuff up?
Okay, so the live view shot is the full solar disk here, and you can see the active region towards the western limb, the right side of the sun here. And this sunspot has actually defied the odds because it's so active that it was forecasted to produce an M-class flare. It still is actually above a 50% chance to produce at least an M-class flare today or tomorrow. So that's what we're looking at here. There's a very large sunspot to the right. You can see the dark sunspot, and just to the left of that is active region 1787. That region is a little more pointed towards Earth now than 1785 was.
From Matt's observatory in Prescott, Arizona, and we're looking at this significant sunspot that is currently rotating around Earth. Now, Matt, maybe you can tell us. I like to always step back a little bit because a lot of our watchers know very little about the sun, and know very little about what it is. And I know some of you out there maybe get offended by this, but the sun is actually a star. And Matt, maybe you could talk more about what you know about the sun, because you obviously image
Sure.
it frequently, and share your thoughts on it. And I'm going to bring up, while we're looking at some of these live feeds, I'll show some other images that you took recently of the sun to show some of the sunspot activity that we'll talk more about in a second.
Sure. Well, as I'm talking about this, I'm going to be referring to the live image. So the sun has an 11-year active cycle, which we're right at the peak this year. So that just means that the activity, but I think if they were to produce a CME today, it's likely that it would still, at least at a glancing blow, strike Earth.
Yeah, and in fact, a couple of things, guys. If you're watching this on Slooh.com, the homepage of Slooh, you're also getting a high-res version of the sunspot location provided from these feeds. So you can also see the feed itself through the live video that we have, but also a high-res version of it is also located at Slooh.com. So you can go there as well. There's also a Slooh conversation section. So go there if you want to ask some questions. That's where we will take them if we have time. This show is about 25 minutes today to about 11:30 a.m. Pacific. So if we have time, we'll try to get to them. But you can also interact with space explorers around the world who watch these shows. So what we're going to be doing is giving you different looks. Matt's, at some point when we get further along, we'll zoom in on some of these flares and some of this other activity that's happening on the sun. What you're looking at right now are live images coming. Hi everyone, this is Patrick Palucci with Slooh Space Camera. It is July 9th, Tuesday at 11:10 a.m. Pacific Standard Time, or Daylight Time, and I'm here today with a special solar show giving you a live view of this amazing sunspot activity that's taking place on the sun currently. The name of this sunspot is AR1785, and what makes this sunspot so significant is the size of it. And what we're going to be doing today is giving you a live view of it from a world-class observatory located in Prescott, Arizona. Now, on with me today is longtime Slooh friend and observatory owner Matt Francis. Matt, how are you?
I'm doing good. Thank you, Pat. Glad to be here looking at this sunspot today.
Excellent. So, for those of you who don't know where Prescott, Arizona is located, I'm going to show you really quick Matt's location before we get rolling so you understand what's happening here. This is going to be loading up a Google Earth little map, and unfortunately, this is the same location where all of the 19 firefighters recently passed away. So our thoughts and prayers are out to those families who lost loved ones. It's really too bad. It's the wildfire situation out there has been bad. Hopefully Matt's been telling me it's contained, and so that's good to hear. But we're also sorry to hear about the death of those firefighters. Matt's facility of it that I've put together that are from a previous show, and that's the supermoon, as you can see. Other nice shots here of Matt's facility looking at. So this is a significant facility that Matt owns and operates, and he's a significant partner for Slooh.